Innovation begins with a single idea. At every step of ideation, MakerBot has the 3D printing solutions to help guide you and give you focus. This is the power of process and iteration, the collaborative space that allows you to imagine, create, and grow. Powerful new features streamline 3D print preparation, allowing for better processes and ultimately, better results. This is the freedom of experimentation, so you can move to the next idea, constantly creating, modifying, and making. MakerBot is more than a 3D printer, and our 3D printers offer more than you'd expect. With connected accounts, you can store files in the cloud or even connect to and control multiple printers on multiple networks. Accelerate the design process and streamline your workflow with solutions built for rapid iteration and proven returns. Less debating and more trying it out. Less doubt and more conviction. Less planning, more process. MakerBot, ideas in the making.
Moving faster is everything to us. It's all about speed to market. Imagine if the market is this wide open pie that nobody's had a slice of yet. First person there gets the whole pie. That's the goal.
Mishimoto is the world leader in aftermarket performance cooling products for the automotive, diesel truck, motocross, and ATV markets. We specialize in cooling products like radiators, coolant hoses, fan shrouds, intercoolers. Upgraded cooling is really important for people who are taking their car or their truck to the track, automotive enthusiasts.
My name is Steve Wiley. I'm a product engineer here at Mishimoto Automotive, and my job is to take a project from concept to reality. Before we had a 3D printer, the way that we could really do it was by using either cardboard or sheet metal and piecing together as adequate of a prototype as we possibly could. A lot of times that fell short because you can't simulate complex geometry with basic sheet metal parts.
This is what you get with a stock intercooler, plastic end tanks and the tube and fin core. From the initial stock one, we made a rough prototype using wood for the core, and then we 3D printed the end tanks. The important thing here is that we're able to test fit this on the car and make sure that our dimensions are exactly correct. We were then able to go straight to production with this type of bar and plate intercooler. We saved at least 5 or 6 weeks of mass production time, and we were able to get this product to market that much faster.
Instead of having to wait for a factory to make one, now I just can simply take a part and send it right to the printer, and while it's working, I can also be working, so it's kind of like having an extra set of hands to do the job for me.
We chose the Z18 because there were different color options that we could choose for printing. The printing time was really fast, the consumables were really inexpensive, and the build plate size was a lot bigger.
Many times the silicone piece is larger than 8 inches. By having the 18-inch build height and the larger build plate, we're then able to just take that and print it as one solid model, which gives us the confidence that we have a full, accurate representation of what the factory is going to produce.
When I first started, it might have taken us 2 years in some cases to develop and bring a product to market. Where we are today, we're a fraction of that. A lot of that's through the tools that we've brought on site to help us with it, such as 3D printing, such as some of the actual physical mechanical tools that we have for manipulating materials. Some of it's just through the test equipment that we have. At Mishimoto, 5 years from now, I can see us having a wall of 3D printers and expanding with the business because it will continue to allow us to get to market faster.
We asked ourselves, how could we create the most powerful, most reliable 3D printer designed for the desktop? Introducing the Form 2 high-resolution 3D printer. It starts at the heart of the machine, the optical engine. A high-powered laser is guided by custom galvanometers, creating each layer with exceptional detail. A sliding peel mechanism gently removes the part from the print bed, while a wiper glides across the optical window. A responsive heating system warms the resin to a consistent temperature. This creates a reliable print process, producing beautiful parts without sacrificing speed. It features a 40% larger build volume and a new smart resin system that automatically refills the tank when levels are low. To make printing simple, we've added wireless connectivity and a touchscreen display. Now you can upload over Wi-Fi, manage your queue, and receive notifications when your print's complete. All this has been designed to work together with our world-class software and cutting-edge materials to deliver professional results. The Form 2, the most advanced desktop 3D printer ever created.
Within 24 hours, we have our 3D printed part ready to give to the surgeon to ensure proper care and to ensure a good evaluation for the surgery. I'm Lars Brouwers. I'm a surgical resident in training, and furthermore I'm a medical researcher in which I investigate the added value of 3D printing in complex fractures and especially acetabular fractures. The Elisabeth II Steden Hospital is a major level 1 trauma center in the southern part of the Netherlands, and we take care of almost all the heavily injured patients, and they arrive on a daily basis by helicopter or by ambulance. We know it's very hard to understand the fracture patterns of complex fractures by using only 2D CT or X-ray. We started to print with the Ultimaker. Our goal was to investigate if 3D printing can be of added value in classifying acetabular fractures. Because of the classification, some people will take other steps or other types of surgery. So it works like this. The patient arrives in our hospital by helicopter or by ambulance. Once we've investigated the patient, we will make a CT scan and an X-ray of the injured part of the patient. And once the CT is ready, we've got our DICOM files. Within 5 or 10 minutes, our DICOM files are ready to convert into an STL file and finally into a 3D printed file. So within half an hour after arriving the patient in the hospital, our Ultimaker is up and running, and within 24 hours the print is ready to give to the surgeon or give to the resident to ensure a good evaluation for the surgery. We need to explain the operation to the patient, and using X-ray and 2D CT, it can be very hard for the patient to understand what is going to happen in his or her body. And with help of a 3D printed model, we think that our explanation can be more clear, can be better, and a patient has got a better understanding of what we are doing and what he or she has to do after the operation. The most important conclusions of our research is that 3D printing is of added value. We measured the classification in terms of intra-observer agreements. We call it kappa. And a kappa of 0 means that there's no agreement over the classification, and a kappa of 1 means there's a total agreement between the observers. And we noticed that when using X-ray and 2D CT, the most experienced surgeons and the students only reached a kappa of 0.2. But when they used 3D printed models, they reached a kappa of almost 0.7, which internationally can be seen as a good inter-observer agreement between the observers. That's really showing us that 3D printing can be of added value, for example, especially for the younger generation. By doing a lot of research, we hope that we can prove that 3D printing can be of added value in patient satisfaction, in surgical satisfaction, in reduction of operation time, and in the health-related quality of life for the patient, because that's the most important thing.